The overall goal of this procedure is to provide a simple and effective protocol for synthesizing drug-loaded disulfide cross-linked micelles for targeted drug delivery.
This method can help answer key questions in the nanomedicine field, such as how to effectively produce stable nanoformulations. The main advantage of this technique is that it allows us to easily synthesize disulfide cross-linked micelles on a large scale, which is extremely desirable for clinical studies in patients.
To begin this procedure, add 2 grams of monomethyl-terminated polyethylene glycol monoamine to a round-bottomed flask. Add 10 milliliters of anhydrous DMF to dissolve it. Chill on ice. Add 3 equivalents of hydroxybenzotriazole, 3 equivalents of DIC, and 3 equivalents of di-FMOC-protected lysine to a round-bottom flask. Next, add 10 milliliters of anhydrous DMF. Stir the mixture for 20 minutes on a magnetic stir plate. Then, add the mixture to the round-bottom flask containing monomethyl-terminated polyethylene glycol. Remove the round-bottom flask from the ice bath, then stir overnight at room temperature. Once the stirring is complete, confirm the completion of the reaction as detailed in the text protocol. Add 200 milliliters of ice-cold ether to the reaction flask. Centrifuge at 6,000 times G for 6 minutes at 4 degrees.